Welcome you all. In this session, I will explain about hydraulic turbines. So this is module number 4 in a turbo machine subject. So first of all, I will explain about give the introduction about the hydraulic turbines. Hydraulic turbines. The hydraulic turbines are the machines which converts the water energy into mechanical energy. See, these hydraulic turbines are used in hydropower stations. In hydropower stations, the energy available in the water is get converted into electrical energy. That means here the hydraulic turbines are the machines or a setup which convert the water energy. So that water energy is also called as hydropower into mechanical energy. So in order to produce electricity, we require some mechanical energy, so that mechanical energies get converted into electrical energy by use of generators. The water energy may be either in the form of potential energy as we find in dams, reservoirs, or in the form of kinetic energy in flowing water. Say in hydropower stations, say initially water is made to store in a reservoir. So that means the dam is constructed across the rivers. So here the water is stored for certain height. So that is called as a height or and maintained in a reservoir. From that reservoir, the water is made to flow through the penstock. The penstocks means there are passages. So through their passages, the water is supplied from the dam to the turbine unit. So while it is flowing through the penstock, the potential energy is get converted into kinetic energy. So initially, so when water is made to store across the in a dam means the potential energy is available there. So then it is get converted into kinetic energy while it is flowing through the penstock, as well as when it is get converted in a while supplied or uh, get discharged to the nozzle. The shaft of the turbine directly coupled to the electric generator. So then while water is flowing through the turbines, now this potential energy as well as kinetic energy is get converted into mechanical energy. So that causes the rotation of the turbine shaft. So this output shaft of the turbine is directly coupled to the electric generator. That means, so now this the available mechanical energy in the turbine is get converted into electrical energy. And this whole setup is called as a hydro power plant, or the power available here, that is called as a hydroelectric power. Coming to the classification of hydraulic turbines, the water turbines are classified into various kinds according to the some conditions. The first one is according to the action of water on blades. Second one is based on the direction of fluid flow through the runner. And third one is the specific speed of the turbine. So based on these three different conditions, the turbines are further classified as, so based on the action of the water on the blades, so this may be classified into impulse turbine, and second one is called as reaction type of the turbines. In impulse turbine type of the turbine, the pressure of the flowing fluid over the runner is constant. So in a impulse turbine, the pressure remains constant. There is a change in velocity occurs, and here the pressure drop occurs only in nozzles. That means when water is get discharged from the nozzle, so that we can observe the change in pressure. So in practice, this pressure turns to be an atmospheric pressure. So while it is get exited from the turbines, it is in what now? The atmospheric pressure. All the available potential energy at the inlet will completely used in producing kinetic energy, which in turn utilized to the purely impulse effect to produce work. So that means while water is flowing through the runner or through the turbine, the pressure remains constant. The whatever the kinetic energy is available while it is get exited from the nozzle, it is completely utilized by the runner, and that is get converted to mechanical work. Reaction type of the turbines. In reaction turbine, the turbine casing is filled with the water. So in case of reaction, the total casing, the turbine casing is filled with the water. The water pressure changes during flow through the rotor in addition to kinetic energy from the nozzle. So in reaction turbine, we can observe there is a change in pressure from the inlet to the exit. As a whole, both potential energy and kinetic energy are available at the inlet of the reaction turbines for producing power. So this is the difference between impulse turbine as well as reaction turbines. So based on the direction of flow fluid through runner, the hydraulic machines are classified into, first one is the tangential or peripheral flow, second one is the radial inward or outward flow, third one mixed or diagonal flow, fourth one axial flow types. In tangential flow machines, the water flows along the tangent to the path of rotation of the runner. That means, so here the water is supplied or flowing at certain angle to the axis of the rotation of the wheel. So that is, for example, for such type of the turbines are Pelton wheel turbine. So based on direction of flow of fluid through the runner, either once again it is classified into radial flow machines. In radial flow machine, the water flows along the radial direction and flow remains normal to the axis of the rotation as it passes through the runner. So it may be inward flow machine or outward flow machine. So in inward flow turbines, the water flows along the radial direction and flow remains normal to the axis of rotation and finally leaves at inner periphery. So in inward flow machines, the inlet of the fluid or inlet of the water taking place at the outer periphery of the runner. So then that water is flows through the surface of the rotor. Finally it is get exited at the inner periphery of the runner. So such machines are known as inward flow machines. Example for that one, Francis turbine. But in case of outer flow machines, it is the flow direction is opposite to the inward flow machines. That means the inlet of the fluid is taking place at the inner periphery of the rotor, then water flowing along the surface of the rotor. Finally it is get exited from the outer surface or outer circumference of the runner. Mixed or diagonal flow. So in this type of turbine, the flow of fluid entered at outer periphery of the machine passes over the inner runner inwardly and leaves axially or parallel to the axis of the rotation and vice versa. So mixed or diagonal flow means here the fluid will take the two different directions. So in the inlet occurs in radial direction. That means from that one, after inlet, this water flows in inward direction or in the exactly perpendicular to the direction of the rotation of the shaft. So then it is get exited in parallel axis of the shaft. That is called as axial direction. That means here there is a combination of the both the radial flow as well as the radial inward as well as axial exit. The example for such type of the turbines are modern Francis turbine as well as Darius turbine. Next one is axial flow turbine. So in this type of turbine, the water flows along the direction parallel to the axis of rotation. So here both inlet as well as exit taking place at the same axis of the rotation. In this case, in axial flow directions, in axial flow cases, the inlet diameter as well as exit diameters are same, and here the blade velocity is also taken as a same, that is u1 is equals to u2. The example for such type of the turbines are Kaplan turbine or propeller type of the turbines. Based on specific speed, the turbines are classified as low specific speed turbine, which employs high head in the range of 200 meter up to 1700 meters. So such low specific speed machines also called as high head turbines. So that means here the head is maintained as so far very high, that is a 200 meter to 1700 meter. So these machines requires low discharge. So in order to get the desired power, the low discharge is sufficient. So because of what? Higher head. The examples for Pelton wheel turbine. So here specific speed is maintained in the range of 10 to 30 for a single jet. In case of double jet is used, at that time the specific speed ranges from the 30 to 50. Second one is a medium specific speed, so which employs moderate heads in the range of 500 meter to 200 meter. The examples for that one, Francis turbine. So here the specific speed ranges from the 60 to 400. Then high specific speed turbines, so which employs very low heads in the range of 2.5 meter to 50 meter. So these requires high discharge. Examples for Kaplan or propeller type of the turbines. Here the specific speed ranges from the 300 to 1000. So these are the classifications of hydraulic turbines. So here the classification of the turbines are shown in summarized here based on the classification based on the specific speed. So in case the specific speed ranges from the 9 to 30 in SI units, that is a Pelton wheel with the single jet. In case the specific speed ranges from 30 to 50, that is a double jet or more jet Pelton wheel turbines. In case the specific speed ranges from 50 to 260, that is called as a Francis turbine. In case the specific speed ranges from the 260 to 850, that is a Kaplan or propeller turbine. In this session, we studied about what do you mean by hydro power stations or hydraulic turbines. So what are the classifications of the hydraulic turbines? Thank you.